purpose of NEC Section 230.71 is to make sure that service disconnects can be operated as a group from one single spot. The National Electrical Code doesn't mention a specific distance allowed between the disconnects, but the requirement is that the disconnects must be capable of being operated at the same time and within sight of a single area. Considering disconnects positioned 35 feet from each other, it's unlikely they could be operated at the same time while maintaining visual sight from a single location. Due to this, the setup would likely not be acceptable according to NEC Section 230.71. The general consensus among electrical inspectors leans towards positioning the disconnects as closely as possible. This proximity is intended to guarantee they can be operated together as a group from that singular location. At times, installing the disconnects in their own separate enclosures may be needed, but even in these instances, the enclosures should still be kept as close together as possible. The key aspects to think about related to NEC Section 230.71, which focuses on grouping service disconnects, includes interpretation and application of the code. First, the code's intent centers on allowing the ability to operate all service disconnects at the same time from a single location. This provides a method to de-energize the entire service quickly during emergencies or maintenance. Second, the phrase "in a readily accessible location" means that the disconnects must be reachable without having to climb over obstacles, remove barriers, or use tools to gain access. The location should be clear and unobstructed. Third, the code doesn't state a specific maximum distance between disconnects, but it does use the phrase "grouped." This implies they should be close enough to allow for simultaneous operation. Inspectors often interpret this to mean within arm's reach or a few feet of each other. Fourth, if disconnects are 35 feet apart, they would likely not meet the intent of being grouped for simultaneous operation, especially if there are obstructions or other factors hindering easy access to all disconnects at once. Fifth, the phrase "suitable for use" means that the disconnects must be rated for the available fault current at the service location. They must also be appropriate for the environmental conditions, such as wet or corrosive locations. Sixth, the number of disconnects allowed. The NEC permits up to 6 service disconnects for each service. This rule is intended to provide flexibility while still maintaining the ability to de-energize the service with a limited number of operations. Seventh, practical considerations come into play. Even if the code doesn't specify an exact distance, consider the practicality of operating the disconnect simultaneously. Can a person easily reach all disconnects from a single standing position? Are there any obstructions or safety hazards that would impede operation? Eighth, local amendments might exist. Some local jurisdictions may have amended the NEC to include specific distance requirements or other regulations related to service disconnect grouping. It's important to check with the local authority having jurisdiction, or OJ, for any additional requirements. Ninth, the physical arrangement of the disconnects matter. They should be arranged in a way that allows for easy identification and operation. For example, labeling each disconnect clearly and providing adequate working space can improve safety and usability. 10th, exceptions can occur. In some cases, exceptions to the grouping requirements may be granted if there are practical difficulties in meeting the standard requirements. However, these exceptions typically require approval from the AHA and must provide an equivalent level of safety. 11th, documentation is important. Keep records of the service disconnect arrangement, including the location of each disconnect, the rating of the disconnects, and any applicable exceptions or approvals from the AHA. This documentation can be helpful for future maintenance, inspections, or modifications. 12th, consider future expansion. When designing the service disconnect arrangement, consider the possibility of future expansion or modifications to the electrical system. Providing extra space or conduit capacity can make it easier to add or relocate disconnects in the future. 13th, coordination with other trades is essential. Coordinate the location of service disconnects with other trades such as plumbers and HVAC contractors to avoid conflicts and ensure that all equipment can be accessed and maintained safely. 14th, ongoing maintenance is crucial. Regularly inspect and maintain service disconnects to ensure they are in good working condition. This includes checking for signs of damage, corrosion, or overheating, and testing the operation of the disconnects to verify they function properly. 15th, training is necessary. Ensure that personnel who operate or maintain service disconnects are properly trained in their safe and correct operation. This training should include instruction on the hazards of electricity, the proper use of personal protective equipment, and the procedures for de-energizing and re-energizing electrical equipment. 16th, emergency procedures must be in place. Develop and implement emergency procedures for responding to electrical incidents such as fires, shocks, or equipment failures. These procedures should include instructions on how to quickly de-energize the service using the disconnects and how to contact emergency services. 17th, consider accessibility for people with disabilities. When locating service disconnects, consider the accessibility requirements of the Americans with Disabilities Act, or ADA. Ensure that the disconnects are located within reach of people with disabilities and that there is sufficient clear space around the disconnects for maneuvering. 18th, use appropriate signage. Install appropriate signage to identify the service disconnects and provide instructions on their operation. This signage should be clear, concise, and easy to understand, and it should be visible even in low light conditions. 19th, consider remote operation. In some cases, it may be desirable to provide remote operation of the service disconnects. This can be accomplished using remote-controlled switches or circuit breakers. However, remote operation should only be used in conjunction with appropriate safety interlocks and procedures to prevent accidental or unauthorized operation. 20th, consult with a qualified electrical engineer. If there is any uncertainty about the correct application of the NEC requirements for service disconnect grouping, consult with a qualified electrical engineer. An engineer can provide expert guidance and ensure that the electrical system is designed and installed in accordance with all applicable codes and standards. 21st, always prioritize safety. When working with electrical equipment, always prioritize safety. Wear appropriate personal protective equipment, follow safe work practices, and never take shortcuts that could compromise safety. 22nd, understand the difference between service equipment and distribution equipment. Service equipment includes the main disconnects and overcurrent protection devices that protect the entire electrical system. Distribution equipment includes panel boards and circuit breakers that distribute power to individual circuits. 23rd, coordinate the service disconnect location with the utility company. The utility company may have specific requirements for the location of the service disconnects, such as clearances from other equipment or structures. 24th, consider the environmental conditions. The location of the service disconnect should be chosen to minimize exposure to environmental hazards such as moisture, corrosion, or extreme temperatures. 25th, use listed and labeled equipment. All service disconnects and related equipment should be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or all. This ensures that the equipment has been tested and found to meet applicable safety standards. 26. Provide adequate working space around the service disconnects. The NEC requires that there be sufficient working space around electrical equipment to allow for safe operation and maintenance. This working space should be clear of obstructions and should provide adequate headroom and access. 27. Use proper grounding and bonding techniques. Proper grounding and bonding are essential for electrical safety. All service disconnects and related equipment should be properly grounded and bonded in accordance with the NEC requirements. 28. Install surge protection. Surge protection devices, or SPDs, can help to protect electrical equipment from damage caused by voltage surges. SPD should be installed at the service entrance and at other strategic locations throughout the electrical system. 29th. Perform regular inspections and testing. Regular inspections and testing of the electrical system can help to identify potential problems before they become serious. Inspections should be performed by a qualified electrical inspector, and testing should be performed using appropriate test equipment. 30th. Keep accurate records. Keep accurate records of all electrical work, including the location of service disconnects, the rating of the equipment, and the results of inspections and testing. These records can be helpful for future maintenance, troubleshooting, or modifications. 31st, follow manufacturer's instructions. Always follow the manufacturer's instructions for installing, operating, and maintaining electrical equipment. The manufacturer's instructions provide important information about the safe and correct use of the equipment. 32nd, use qualified personnel. All electrical work should be performed by qualified personnel who are trained and experienced in the safe and correct installation, operation, and maintenance of electrical equipment. 33rd, understand the NEC requirements for service entrance conductors. Service entrance conductors are the conductors that run from the utility company's transformer to the service disconnects. The NEC has specific requirements for the size, type, and installation of service entrance conductors. 34th, consider the load calculations. The size of the service entrance conductors and the service disconnects must be based on the load calculations for the building or facility. The load calculation should take into account all of the electrical loads that will be connected to the electrical system. 35th, use appropriate overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. The overcurrent protection devices must be sized correctly to protect the conductors and equipment in the circuit. 36. Understand the requirements for selective coordination. Selective coordination is the practice of coordinating the overcurrent protection devices in an electrical system so that only the overcurrent device closest to the fault will open, minimizing the impact of the fault on the rest of the system. 37th, use arc flash protection. Arc flash is a dangerous electrical hazard that can occur when there is a fault in an electrical circuit. Arc flash protection, such as arc-rated clothing and equipment, can help to protect workers from the hazards of arc flash. 38th, understand the requirements for ground fault protection. Ground fault protection is used to protect people from electric shock. Ground fault protection devices, such as ground fault circuit interrupters or GFCIs, are required in certain locations such as bathrooms and kitchens. 39th, consider the use of energy-efficient equipment. Energy-efficient equipment can help to reduce energy consumption and save money on utility bills. When selecting electrical equipment, consider the energy efficiency ratings of the equipment. 40th, understand the requirements for emergency power systems. Emergency power systems are used to provide power to essential loads during a power outage. The NEC has specific requirements for the design, installation, and testing of emergency power systems. 41st, consider the use of renewable energy sources. Renewable energy sources, such as solar panels and wind turbines, can be used to generate electricity. When considering the use of renewable energy sources, consult with a qualified electrical engineer to ensure that the system is designed and installed in accordance with all applicable codes and standards. 42nd, understand the requirements for electrical safety and hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. The NEC has specific requirements for the design, installation, and maintenance of electrical equipment in hazardous locations. 43rd, consider the use of smart grid technologies. Smart grid technologies are used to improve the efficiency, reliability, and security of the electrical grid. These technologies include smart meters, advanced metering infrastructure, or ARMI, and distribution automation systems. 44th, understand the requirements for electrical safety in healthcare facilities. Healthcare facilities have unique electrical safety requirements due to the presence of patients and sensitive medical equipment. The NEC has specific requirements for the design, installation, and maintenance of electrical systems in healthcare facilities. 45th, consider the use of uninterruptible power supplies, or UPS. Uninterruptible power supplies, or UPS, are used to provide backup power to critical equipment during a power outage. UPS systems are commonly used in data centers, hospitals, and other facilities where power interruptions cannot be tolerated. 46th, Understand the requirements for electrical safety in industrial facilities. Industrial facilities have unique electrical safety requirements due to the presence of heavy machinery, hazardous materials, and other industrial hazards. The NEC has specific requirements for the design, installation, and maintenance of electrical systems in industrial facilities. 47. Consider the use of power quality monitoring equipment. Power quality monitoring equipment can be used to monitor the quality of electrical power and identify potential problems such as voltage sags, voltage swells, and harmonic distortion. This information can be used to improve the reliability and efficiency of the electrical system. 48. Understand the requirements for electrical safety in commercial buildings. Commercial buildings have a wide range of electrical safety requirements depending on the type of building and the activities that take place within the building. The NEC has specific requirements for the design, installation, and maintenance of electrical systems in commercial buildings. 49th. Consider the use of demand response programs. Demand response programs are used to reduce electricity consumption during peak demand periods. These programs can help to reduce the strain on the electrical grid and lower electricity costs. 50th. Understand the requirements for electrical safety in residential buildings. Residential buildings have specific electrical safety requirements to protect residents from electric shock and fire hazards. The NEC has specific requirements for the design, installation, and maintenance of electrical systems in residential buildings.